The moon buggies left on the moon decades ago. Could they still run today? Actually, there are 3 manned rovers on the moon. They were used by the Apollo 15, 16 and 17 missions and were left there after the missions ended. The modularized equipment stowage assembly, which held parts that would later be installed on the rover. Once both astronauts were on the surface, they could finally start deploying the rover. When Apollo 15 used the rover for the first time, they set up a camera to film it. So let's go step by step and explain this moon buggy clearly. How it was stored on the moon, how it unfolded, and why they were all left behind. Actually, the astronauts first rolled it back, then saw 2 deployment tapes used to control the unfolding process. One astronaut held the right side tape. The other astronaut climbed back up the ladder to pull a handle on the right side of the porch. This handle activated a complex lever system, releasing 3 pins. To understand why it was so hard, we need to review the Apollo program's transportation chain. NASA explored the moon through the Apollo program, first landing astronauts on the lunar surface in 1969. For about 3.5 years after, the astronaut on the right slowly pulled the tape. This rotated the stowage drum, releasing 2 more guide cables. The other astronaut grabbed the deployment latch, using lunar gravity to gently pull the rover out bit by bit. Mid-deployment, the pivot point shifted to a lower support arm. The chassis rotated around this new point. When the rover reached about a 45-degree angle, a key action was triggered. A center cable tightened through pulleys, releasing 2 pins that held it folded. Powerful torsion springs instantly activated, and the 2 sides of the chassis sprang outward. The rear chassis, being more free, moved first. The wheels also had internal spring mechanisms that wanted to rotate outward but were previously locked by a hub. As the rear chassis fully opened, it tightened an internal cable, pulling a key pin and releasing the struts. The wheels then swung out and locked into place. This happened fast, almost instantly. The front chassis unfolded a bit slower. The support arm end had an area called the walking hinge. As the rover continued to rotate, this part forced a lever down, releasing a latch and letting the structure keep turning, lowering the chassis further. Once the rear wheels touched the ground, so the third actual landing was Apollo 14. This time they came up with an idea. They brought a 2-wheeled handcart, officially called the Modular Equipment Transporter. The 2 front wheels would snap into place, a process similar to the rear wheel's cable tightening, pin pulling, strut releasing and the wheels locking. Afterward, the astronauts released the 2 guide cables. Those 2 deployment tapes mentioned earlier. They'd only used the right one so far. Now it was time to pull the left one. Pulling the left tape released tension on the center guide cable. Only a few hours per excursion. That wasn't enough time to get very far. So the conclusion was straightforward. If they had a drivable car or vehicle, they could go much farther and do a lot more science. NASA of course realized this early on and started developing lunar surface vehicles long before. But the earliest concept vehicles were often very bulky. One concept was called MOLAB, meaning Mobile Laboratory. It was almost the size of a small truck. How heavy was it? It would have required an extra Saturn V launch just to send it up. The rover was driven to the other side of the lunar module. So that plan wasn't realistic. What's more problematic, the lunar module was the only thing that could land on the surface. If you wanted to get a vehicle to the moon, you had to fit it inside the lunar module. But space in the lunar module was already tight. It sounded like trying to fit a car into a refrigerator. So more research and design followed. The vehicle had to be light enough and foldable enough to cram into the compartment. NASA contracted the actual construction to 2 companies. They started building just months after Apollo 11 and finished in time for Apollo 15. The first rover took only 17 months from start to finish, an incredibly fast pace. So the question is, how did it actually fit inside the lunar module? We'll get to that in detail later. The experience from the rovers didn't stop with the Apollo era. It helped shape future plans, like the robotic rovers on Mars. NASA is now returning to the moon, planning to build a modern lunar terrain vehicle, aimed for use in the early next decade, and is now on display at the Kennedy Space Center in Florida. These rovers cost a total of $38 million. Adjusting for today's money, that's close to $300 million. Its dimensions were similar to a regular car, about 3 meters long, but its weight on Earth was surprisingly light, roughly that of a large motorcycle. Because it was designed for low gravity. On the moon with even less gravity, its effective weight would drop to a ridiculous level. If needed, the astronauts could even lift it. Key components included the chassis, the frame, 4 wheels, 2 seats, the display control console with the center joystick, a color TV camera to send pictures back to Earth, communication antennas and gear to talk to mission control, and the rear equipment pallet, which held lots of tools and sample containers. You'll see some parts wrapped in a polyester film. It looks like golden tin foil, but it's not for decoration. It's for thermal protection of sensitive equipment. When the rover was parked, the astronauts would open some panels to let heat escape, to keep things from overheating. A crucial point is, if you tried to drive this thing directly on Earth, you'd have big problems. Because it used very light materials to save weight. Under Earth's gravity, it might just collapse under its own weight. For ground testing, they did build a stronger, heavier test vehicle. The actual flight rovers that went to the moon were made mostly of lightweight aluminum. On the moon, it could carry over twice its own weight in payload. That payload included 2 astronauts' various science gear, and eventually the moon rock samples they collected. The wheels were one of the smartest designs. Rubber tires were too risky, a single puncture could leave astronauts stranded far from the lunar module. So they used woven wire mesh tires, with titanium alloy chevron treads attached, for better grip and to avoid sinking into moon dust. Each wheel had a stiff internal frame, to keep the mesh from deforming too much. When hitting obstacles, it could handle a step about 25 centimeters high. Even better, each wheel had its own independent electric motor, meaning the vehicle could still keep going. Fenders were also fitted on the wheels, to control moondust spray. Astronauts described moondust like powdered snow, but it's electrostatically charged and sticks to everything. Once on, it's very hard to clean off. Steering wasn't just the front wheels moving, but all 4 wheels working together. All controlled by that center joystick. Push forward to go forward, tilt left or right to turn, pull back to slow down or stop. To reverse, you'd press a button, flip a switch, then pull the joystick back, and the vehicle would go backwards. The joystick sent electrical signals to the mechanical parts, making the wheels spin. Power came from 2 sets of silver zinc batteries. But they wouldn't run the batteries to empty. For safety, they'd drive to the farthest planned point first, then work their way back. Think of it as a safety bubble. As time went on, that bubble would slowly shrink. Because if the rover broke down, the astronauts had to be able to walk back to the lunar module on their life support. So the farthest they could go was limited. I recall the number given was about 95 kilometers. That range ensured they could get back if something went wrong. Driving on the moon also felt completely different. Low gravity made inertia behave weirdly. Stopping quickly or changing direction suddenly was harder to control. They even complained sometimes. The wheels would bounce so lightly, it felt like only 2 were touching the ground. Apollo 15, 16 and 17 were considered the more important extended science missions. Compared to earlier ones, they stayed on the surface longer, went farther and did more experiments. The lunar rover made all that possible, and it looked pretty cool driving around too. Of course, there were some hiccups along the way. Apollo 15 landed on a crater rim. The sloped ground made deploying the rover very difficult. Another time the front wheel steering failed at first. Luckily they could still steer with the rear wheels, and the mission wasn't ruined. An astronaut's tool snagged a fender and tore part of it off. They had to improvise a repair on the spot, because without the fender, moondust would spray everywhere. But overall the lunar rover was a huge success. It let them cover a much wider area, see more amazing landscapes, and made science sampling way more efficient. Even today, the rock samples they collected are still being studied at NASA and universities worldwide. Comparing distances makes it even clearer. The first landing mission, their walking range was tiny. But on the final mission, their total driving distance reached 36 kilometers. A massive difference. So how exactly was it packed into the lunar module? We need to look at the lunar module's structure. The lunar module had 2 parts: the ascent stage, where the astronauts lived on the surface, and the only part that would lift off to return to space. And the descent stage, the part that landed with the engines containing fuel and oxidizer tanks, the part left behind on the moon. Around the descent stage were 4 triangular storage compartments for holding various equipment, like water, oxygen, science experiment gear, even the TV camera. These areas were called quadrants, quadrant 1, 2, 3 and 4. The lunar rover was stored in quadrant 1. Simply put, this was the only spot in the lunar module with enough space to fit it. The folded rover sat in this triangular bay, secured to a set of space support equipment, designed specifically to help deploy it on the surface. The available volume was about 1 cubic meter, roughly the size of a refrigerator. Now you can understand why it had to fold down to an extreme degree. Deploying the rover was a complex, precise chain of actions they had to prepare before deployment. The outside of the lunar module had a part called the porch. As the commander backed down the ladder, he would reach left and pull a dandle. This lowered the mesa. What's truly amazing is how, under last century's industrial conditions, they built a vehicle that could drive in a vacuum with low gravity on dusty, cratered terrain. Even more critical, they couldn't just make it any size they wanted, because only the lunar module actually landed on the surface, and the space for it was just a tiny compartment. From start to finish, the whole process took about 20 minutes. Deployment happened step by step. The rover had a thermal shield on its underside. As early as the beginning of the 20th century, science fiction writers were already imagining lunar vehicles. Later engineers proposed a bunch of design concepts. Turning it into a real engineering project happened in the 1960s, when NASA got serious about building one. With the pins released, the retention latch would fall to the ground, and the rover began to pivot outward. To start this initial pivoting motion, the rover turned, but not much. Each mission was launched by that super powerful rocket, the Saturn V. The Saturn V carried the Apollo spacecraft at its top. The spacecraft consisted of the Command Service Module and the Lunar Module. The Lunar Module is often abbreviated as LM. The rocket used multi-stage propulsion to push the whole system step by step into space. Then a series of docking maneuvers and adjustments were needed to separate the Lunar Module and prepare for descent. The trip from Earth to the Moon took about 3 days. Upon reaching lunar vicinity, the spacecraft separated, and only the lunar module actually touched down on the Moon's surface, meaning anything you wanted to bring to the lunar surface basically had to come down with the lunar module. In the very first 2 landing missions, the astronauts' range of movement was very limited. They mostly stayed near the lander. Take Apollo 12 for example. If you mapped their walking paths, you'd see they only went a few hundred meters in any direction, about the length of a few city blocks. And wherever they went, they had to carry all their equipment by hand. It was very inefficient. You might recall Apollo 13 had an accident. It never actually landed on the Moon and disengaged from the center latch. A saddle temporarily supported the rover's front weight. As the chassis neared full deployment, the astronauts gave it a more visual nickname, the rickshaw. This little cart's wheels were made of smooth rubber, filled with nitrogen gas. It could carry more gear. But the problem was obvious. On the rocky-crated lunar surface, pulling it was still slow and exhausting. The resistance was huge. Plus the astronauts had limited time outside, letting the saddle complete its final lowering action, setting the rover fully on the ground. Pulling another cable released the saddle assembly. Next came cleanup and setup, removing parts no longer needed, then manually lifting the rover and moving it away from the lunar module. Remember, they could lift it because lunar gravity was so much weaker. The front tripod was also removed. It had supported the weight in the folded state. Then they turned it back into a vehicle, deploying the seats, the front footrests, then the control console. But budgets were tight and rockets were limited. An important part they installed first came from Quadrant 3, the rear equipment pallet, for tools and samples. Then from Quadrant 4 and the Mesa they took the Lunar Communications Relay Unit, the high-gain antenna and low-gain antenna, the 16mm camera mount and the TV camera. With everything installed, the astronauts got into the rover. The commander sat on the left to drive, belted in, and officially began their lunar exploration. The rover had one final job, using its camera to film the astronauts' liftoff from the Moon. This camera was operated from mission control on Earth with a signal delay of over a second. Getting the timing right for liftoff was incredibly hard, but they managed to capture it by the TV standards of the time. Its full name was the Lunar Roving Vehicle, also simply called the Moon Buggy. The English abbreviation is LRV. But only 3 actually flew to the Moon, with the Apollo 15, 16 and 17 missions. A 4th was built for spare parts. These new vehicles will be far more advanced, able to stay on the surface much longer, and all of this starts with those 3 lunar rovers from over 50 years ago. They still sit quietly on the lunar surface to this day.